Hi everybody, welcome to IT Man. So let's solve today the Leetcode problem of the day, a minimum number of days to make M bouquets. Okay, cool. Let's go through the problem statement. So what it basically says is we want to make M bouquets, okay, and we'll be given an integer array called as bloom day, in which every value of the array will tell you that in how many days or in how much time that flower will bloom. And we have to, the only constraint we have to keep in mind here is we have to use k consecutive adjacent flowers in order to make one bouquet, and we have to make such m bouquets. So, and of course if it's not possible to make, we have to return -1. Cool. So let's go through the example here. So here you can see we are given five like a five array of five flowers, and the number of days is mentioned as 1, 10, 3, 10, and 2. It means that the first flower will bloom on the day 1, the second flower will bloom on the 10th day, so on and so forth. And m is given as 3, k is given as 1, so it means we have to make m bouquets using k flowers, which is 1 in this case. Cool. Output here is 3, which is explained here. So let's see. After day 1 it looks like this. We have one flower which is bloomed. After day 2 it looks like this. So we have this and this which are now bloomed. And after day 3 we have this 1, 3, and 2 which are bloomed. So we can pick one flower each and make our 3 bouquets, so hence the answer becomes 3. And similarly in example 2, if you see, so it's a case of -1. Why -1? Because look, we need to make 3 bouquets with 2 flowers each, so it requires 6 flowers in total, but we only have 5 flowers given, so anyway it's not possible, so we have to straight away return -1 here. Cool. I think the problem statement is clear enough. Let's look at the constraints. So the constraint says that the bloom length, like the length of the array would be less than 10 raised to the power 5. The interesting thing to note in the constraint is that the maximum number of days possible is 10 raised to the power 9. So going forward, I'll make you understand why I put emphasis on this point, but okay, so let's try to move to the solution now. So whenever we look at such problems, the first thing which comes into our mind is a greedy approach, but there is a better way to solve this, which is using the binary search. Now what I mean by binary search is, okay, so here as you can see, whenever you'll see a question which tells you to find out something over a range of values, or a range, minimum number of days, maximum number of days over a range of values, you can start thinking in the binary search direction. There are many such questions on such topics. One very famous question is greedy cows. Maybe we'll solve that in the next video. But yeah, so once you start solving such problems, you'll get a hang of it and you'll understand why binary search. So okay, let's try to move to the solution. So the intuition is, okay, so here we are given an array which says 1, 10, 2, let's say 5, and 3. This is our array. K is given as 1 and number of bouquet is given as 3. Cool. So now look how we can apply binary search. So let's say if I take the low value as 1 minimum, okay, and I take high value as, either I can take it as 10 raised to the power 9, which is given in the constraint, that's the maximum which the question can input has, or I can do a smart workaround and take the maximum of this. Okay, it might add to some time complexity, but it saves us a lot of computation. So let's say the max of this whole array is 10. So I can take my h either as 10 raised to the power 9 or 10. Okay. So okay, let's assume I take it as 10 raised to the power 9. I will just leave max for now. Okay, let me just erase it. Cool. Cool. Okay, now what the logic says is, let's say I calculate the mid and it comes out, let's say, to be somewhere around 1000. I'm not telling it's the actual mid, or just for making you understand. Okay, so let's say the mid is 1000. I have some low value, some high value. I'm in the mid of the calculation. So what we can check is, in the mid, so mid is the number of day, so basically it means the 1000th day. We can iterate through the array and check that how many flowers have bloomed already. Okay, so let's say a flower takes I don't know, let's say this takes 5k days to bloom. Okay, so we can always find the answer that okay, 4 flowers have bloomed. We can also keep a track of consecutive flowers which have bloomed, so which in this case would be 3 consecutive flowers and 1 consecutive flowers, and accordingly we can compute our answer. So I let's go to the solution, and I'll try to explain the approach as I proceed coding, and maybe that will help understand this logic even in a better way. Cool. Okay, so here we are. So let's start by taking low and high. So I'm using Python. Feel free to use any language of your choice. The intention here is to understand the logic. So once you know the logic, language is not really pretty much a barrier. So I'm using Python because I'm super comfortable in Python. Okay, so I'll declare two variables, low and high. I'll keep low as 0 and I'll keep high as max of my array. You can also keep it as 10 raised to the power 9. It's your call. Okay, now while I'll write that while low is less than equal to high. Oh yeah, by the way, sorry, I forgot to declare the answer variable. Let's declare it as -1, because in any which ways, if this condition goes false, it will directly return -1. So just return answer here. Cool. While low is less than equals to high, let's calculate the mid. So mid would be low plus high, integer division 2. Okay, cool. Now we remember I told you we have to keep a track of the consecutive length of the flowers bloomed and the number of bouquets we can make. So I'll declare two variables. Let's say c length and b. I'm just keeping it short. Please don't use such vague variable names in interview. I'm just being lazy now. Okay, so b is the number of bouquets and c length is the consecutive length. Cool, let's iterate our array. So let's say for flower in bloom day. Cool. Now we have to check that whether the flower is within a mid range or not. So I'll write here. So let's say if flower is less than equal to mid. So remember I told you mid is the day which we want, which we are checking, because our goal is to minimize the number of days. So yeah, sorry. So if flower is less than equal to mid, it means that it has already bloomed. We will increase our length, consecutive length. Cool. Now we have to check if our consecutive length has reached our k value, because we want k consecutive length, right? So let's say k is 1 in our example. Let's say k is any value, maybe 3. We have to check if we have consecutively seen that okay, 3 flowers have already bloomed consecutively. If so, we will just initialize it back to 0, and since we already have k flowers consecutively, we'll make a bouquet out of it, and we will just increase our bouquet length. Cool, I hope it makes sense till now. And if not, if the flower has not bloomed, we will just keep c length as 0. Cool. Now after calculation, we have to check if we have received, like we have reached our answer or not. So if the number of bouquets we have made is equal to or greater than the one we are expecting, that's m in this variable case, we will initialize our answer as mid. But remember, we need to minimize the number of days, right? So since we are searching over a range of values, maybe we can do it in less amount of days. So here the binary search logic kicks in. We will just decrease our high value to mid minus 1. Okay, else it's low equals to mid plus 1. So if the condition becomes false, we already have our answer stored here. It will just come out of the loop and we'll simply return the answer. Cool. Let's try to run it. It's getting accepted, and let's try to submit it. Yep, accepted solution. Cool. So yep, this was the logic. Do let me know if you want to have further information on how to solve binary search related questions. It's a very interesting topic. And yep, do let us know in the comments what you feel. Thank you for watching.